Hello there and welcome to the online course Easy Geosteering. Here we speak in simple words about main geosteering topics, making them easy to understand. We are moving on to the second part of the course, which will briefly introduce us to the drilling BHA and LWD logging. And today we will list main BHA components and explore rotary steerable system and the mud motor from the geosteering perspective. Let's get started. Drilling BHA is the lower part of the drill string, and the first element is the bit, a cutting tool responsible for breaking rocks to create a wellbore. As the first element in BHA, the drill bit has the maximum diameter, and there is an angular space between the logging tools and the wellbore surface. While drilling, this space is filled with drilling mud, which affects LWD readings in various ways. The larger the gap, the greater the influence of the mud on the measurements. Second point, rotary steerable system and mud motor, specialized tools used to steer the BHA in the desired direction of inclination and azimuth. RSS and motor operate on different principles, and it's essential for the geosteering engineer to understand these differences because they affect our work. Third necessary component, MLWD tool. Its main function is to transmit all downhole data to the surface and also measure inclination and azimuth to define the effect trajectory. Additionally, this type of tool has gamma-ray sensor on board, making this equipment universal. Many projects around the world use only MLWD tools without the need for LWD. However, there are a lot of projects that require more than one gamma-ray curve in real time. That's why we use resistivity, density, and porosity, and other LWD methods. Understanding the physics behind all MLWD measurements is critically important for us because this is the input data for the geosteering model and trajectory decisions. Okay, let's consider the mud motor. The main function is to steer the BHA by changing of inclination and azimuth. For this purpose, the motor has a bend sub, which deviates from the tool axis by a specific bend angle. To change the trajectory, DD engineer makes a slide interval, and it's necessary to stop the top drive rotation first. While sliding, the entire drill string doesn't rotate, and only the bit turns due to the motor and the hydraulic energy of the mud. Second, the bend sub must be aligned in the desired direction. To build inclination, it's oriented up. To drop inclination, it is down. And if you need to change azimuth, the bend sub must be aligned to the right or left. How do you determine the orientation of the motor's bend sub? This is done with the help of MLWD tool, which has sensors that display tool face of the motor, its orientation in space. And the third step, we need to drill the slide interval by creating weight on the bit. Typically it lasts for a few meters. The exact value is calculated by DD engineer for a specific task. Okay, the second function of the motor is to provide additional rotation to the bit for more effective drilling. Mud flows through the motor and rotates a special internal part, the rotor, which transmits this extra rotation to the bit. Okay, and now let's consider pros and cons of the mud motor. Since the motor is a mechanical tool, it's relatively simple and reliable. You just need to monitor the circulation hours and send it to the base for maintenance in a timely manner. Second point, the motor can achieve a higher DLS compared to RSS. In some cases, if RSS cannot provide the desired DLS, it is switched to a motor during the run to provide greater intensity. And finally, the mud motor is not so expensive in comparison to RSS. What about disadvantages? First, it is the lack of drill string rotation during the slide interval, along with all the associated consequences. For example, this can lead to issues in long sections due to high friction, making further drilling impossible without drill string rotation and even dangerous due to the risk of stuck pipe incidents. High friction can also lead to poor BHA steering by making it difficult to align the bend sub. And additionally, it's impossible to obtain azimuthal data during sliding, which is why these intervals need to be relocked with rotation if you want to capture azimuthal data. Point number 2. Generally, any motor is longer than RSS, which leads to a greater blind zone and increases the associated uncertainty. Additionally, RSS has sensors on board, and the gamma ray distance to the bit can be as small as a couple of meters. And finally, here goes borehole surface. When drilling in rotary mode, the bent sub rotates along the entire circle of the tool axis, creating an enlarged diameter. This can also result in spiralization of the wellbore surface, which for example affects the quality of the image log. Okay, let's continue with RSS. The main function is similar to that of the mud motor, to change the drilling direction of inclination and azimuth, but it operates differently. The key difference is that the drill string remains in continuous rotation while drilling, eliminating the need for slide intervals. There are two types of RSS systems, push the bit and point the bit. In push the bit system, special pads extend and retract at a specific moment during tool rotation, pushing against the formation and steering the bit in the desired direction. In point the bit system, there are no pads. Instead, a special shaft inside the tool collar adjusts the bit's orientation without applying a side load. There are significant differences between these two systems, but what we really need to understand is the permanent rotation of the drill string with any type of RSS. Okay, let's have a look at the advantages. First, the permanent rotation allows us to drill longer wells with a lower risk of stuck pipe incidents. Also, azimuthal data is always available since we drill in rotary mode, and there are no slide intervals to relog. Second point, RSS provides a smaller blind zone from MLWD sensors to the bit. Point number 3, DNI and gamma ray on board make RSS a highly versatile downhole tool. Additionally, some RSS systems can have a gamma ray image log, and their proximity to the bit makes them incredibly valuable for geosteering operations. And finally, due to permanent rotation, we get smoother borehole surface. Okay, what about disadvantages? First is DLS. Typically, RSS systems provide lower intensity compared to mud motors. The second point, RSS is a complex high-tech tool consisting of a large number of electronic components. This increases the probability of potential failure compared to a fully mechanical mud motor. And finally, RSS systems are much more expensive. In many ways, they are more convenient to use, but very often everything comes down to cost, and BHA tools are no exception. Alright, we have covered the mud motor and RSS from geosteering perspective. Hope you like this video. Remember, you can enhance your practical skills with the private lessons. Together we will work in StarSteer to apply all modern geosteering tools and drilling simulators, so you can feel like a true geosteering engineer in real time. So stay tuned and give this video a thumbs up. In the next lesson we will continue with the main points of MLWD tools. See you then. Bye bye.